Okay, guys, welcome back. Thank you for bearing with me. I knew we were going to take 3 videos anyway to get through basically 3 pages of notes. It's about 1 page per video, it seems. So what we do need to finish this problem 6. We started it with the park ranger viewing Old Faithful erupting. We want to know how high was the eruption. The park ranger is 5 feet tall, or his eyes are at least 5 feet above the ground. And he saw the top of the geyser at an angle of elevation of 34.6 degrees. Now, one thing to note, that 5, that's really not important in the triangle, but that's important because, again, from the horizontal, there's like 5 feet going on right here. That's not going to be accounted for in our triangle. You know, this is what we're trying to find here. What is this x here? But that's not really the final result. If we're talking about how high the geyser went, we're going to take the x we find using trig and add 5 to it. All right, so you have to be really careful the way this one's worded. The ranger is standing 200 from the feet, from the geyser. So these are kind of both 200. He's standing 200 feet away, but the horizontal, that's still 200 feet, right? So then, if we're focusing up on the triangle up here and then just recognizing if we want total height, we're going to add that 5 in at the end. And again, every trig problem, right, there's the opposite. Here's our right angle. Right here, we're assuming the geyser's shooting more or less straight up. So there's our opposite leg. This must be the adjacent leg. Opposite adjacent, so it looks like it's another tangent problem. And actually that happens a lot with word problems, guys. They're not all, but a lot of word problems are tangent problems. Okay, so the tangent of the angle, 34.6. I'm just realizing I didn't do parentheses on my 4.8 over there. I probably should. It's a good habit. 34.6, tangent of 34.6 equals, tangent is opposite over adjacent, opposite is x, adjacent is 200, excuse me. And so I'm multiplying both sides by 200, right? I'm solving for x, so 200's got to go, multiply both sides by 200. So you'll just have 200 times the tangent of 34.6. Okay, get my calculator over here. 200 times tan, 34.6. 137.97, but it does say right there to the nearest foot. So we would just call this 138 feet. Now, I didn't do a last word problem because I was worried about time, but technically it is good, again, good habit, good form to be in, to answer a word problem with a sentence, right? You were asked a question, answer that question. What is the height of the eruption to the nearest foot? The height of the eruption was about, and I almost did it, right? Remember what we're supposed to do with this, though? Right? This is the 138 feet right here. So I'm glad I caught myself before I finished here. That's 138 feet, but we have to add 5 to that. So 138 plus 5, 143 feet. Right. There we go. Glad I caught it before it's too late. All right, guys, so that ended the day 1 notes. Let's move on to the day 2 notes, though. Just jump right in because we, again, don't want to run out of time for these here. So we're looking at the reciprocal functions now. The reciprocal functions, and they are, here they are. One is called cosecant, and it'll be abbreviated CSC. And it's the reciprocal of the sine function. So it's reciprocal of sine. And you can kind of see it over here. The cosecant of theta is the reciprocal of the sine of theta. 1 over sine theta, that's another way of saying reciprocal. It's like a flipping of the fraction. And remember, sine is opposite over hypotenuse, so cosecant is the flip of that. Hypotenuse over opposite, right? The secant of theta, the secant, that corresponds to, it's the reciprocal of the cosine. Secant is reciprocal of cosine, so it's the flip. Cosine is adjacent over hypotenuse, so secant is the flip of that, hypotenuse over adjacent. And the last one, cotangent. Cotangent corresponds to, it's the reciprocal of the tangent. And again, so it's just the flip. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. Now, one thing I want to tell you on how we're to remember the way I always remember this is the C and the S are opposite, right? With cotangent and tangent, that one's obvious because tangent and tangent is in both names, right? But up here, like cosecant starts with a C, sine starts with S. So C goes with S, and then here, secant goes with cosine, S goes with C. So it's always the opposite letters. It's never S with S or C with C, right? It's S with C and C with S. I don't know if that helps to remember, but cosecant goes with sine, secant goes with cosine. So just think it's always the, S or C, it's the opposite letter when you're dealing with finding these. As far as the rest of it though, to be quite frank, to find cosecant, secant, cotangent, what I do is I find their reciprocals. I find sine, cosine, tangent, and then just flip them. All right, so don't beat yourself up if you don't understand this. They're just the flips, right? Reciprocal means flip the fraction. And we start the same way as before. We label the sides, right? Across on the right angle is the hypotenuse. This leg furthest from the angle is your opposite, and the leg closest to your angle is your adjacent, right? Okay, and then you can see that now it's going to be H over O, H over A, and A over O instead of the reverse of those. Okay, let's see a couple examples. It says find all 6 trigonometric functions. Find all 6. So we're going to do, what are the 6? Sine, cosine, tangent, cosecant, secant, cotangent, right? So those are our 6. Well, to do them, we do need this third side, which it's not there. How the heck are we going to get it? How do I find this third side of a right triangle? Guys, this is a Pythagorean theorem problem. You have to remember the Pythagorean theorem. It is one of the most important tools that we have in math. And it's a simple one. It's one you learn early on in algebra. A squared plus B squared equals C squared, right? We all remember that. It's an important formula. So if I'm going to find this side, it applies to right triangles. It's always A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. So this is my unknown. I'm going to call it like X right now. So that leg squared, which is X, plus the other leg squared, which is 18, that's going to equal the hypotenuse squared. Okay, that's your A squared plus B squared equals C squared. And so I'm just calling this guy X right now. Okay, and now I solve. To solve, right, you go ahead and square those out. All right, what is 18 squared? It's, oh shoot, I had it wrong. 324. What's 82 squared? It's 6,724. All right, we're solving for x, so now we would subtract by 324. All right, order of operations says you do exponents before adding, subtracting, and all that, right? So that's why I did the exponents first. Okay, so x squared equals, so 6,724 minus 324 gives you 6,400. Now we're not quite there. We don't want x squared, we just want x, right? So how do you get rid of a square? What's the opposite of squaring? The opposite of squaring is square rooting. Okay, square root both sides. Square root of 6,400 is 80. So back up here to our picture. So now we know this is 80. Okay. Here's our angle theta. So we identify the sides, right? Across from the right angle is your hypotenuse. So it looks like the 82 is the hypotenuse. Across or furthest away from the angle is your opposite. And the one closest to your angle is your adjacent. Okay. Now, so we're going to have to remember our SOHCAHTOA again. And I want to show you how I set this up. When I'm asked to find all 6, there's a way that kind of makes it easy. So here's how I set it up. I write down, okay, we got sine theta. We're going to find that. We're going to find cosine theta. And we're going to find tan theta. That's the way they kind of come in this, right? Sine, cosine, tangent. So sine, cosine, tangent. And then next to them over here, we'll fill that in a second, I put in the reciprocals. What was the reciprocal of sine? Remember, S goes with C. So this is a cosecant, CSC of theta. C goes with S, so this is secant theta. And then the tangent, the opposite of that is the cotangent, or cot, right, is what it looks like, cotangent. Okay, so these are kind of lined up really nice, because now what's going to happen is for sine of theta, Sine is O over H. O over H, 80 over 82. But remember, the cosecant is just the flip of that. So 80 over to 82 is going to flip 82 over 80. And there you go. That's the easiest way to go, I think. Okay, cosine theta is A over H, right? So A over H, 18 over 82. Secant is the flip of that, the reciprocal of that. So just flip it over, 82 over 18. And tan theta, tan is O over A, right? TOA, O over A, so 80 over 18. And the cotangent is the reciprocal of that. And there you go. Okay, one last example. Same story, we've got two sides. We're going to find the third with Pythagorean theorem. This time the third side is the hypotenuse, right? These are the legs. Legs make the right angle, so this is the hypotenuse over here. That's the unknown. And so if we think about the formula, a squared plus b squared equals c squared, the hypotenuse is like your c, right? It's the guy that's alone. So we'll have the 14 squared plus a 48 squared equals x squared. Right? Leg squared plus leg squared equals hypotenuse squared. Okay, square those out. 14 squared, 196. 48 squared, 2304. Now go ahead and add those. All right, follow an order of operations. That's 2500. And again, once we're at this point, we need to square root. Square root of 2500 is 50. So we now know that this length is 50. And we are going to label sides, right? Here's my angle. The one across, we've already identified that, right, as hypotenuse. We started out that way. The one furthest from the angle is your opposite. The one closest to the angle is your adjacent. And I'm going to set this up exactly how I did before. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay, sine again is opposite over hypotenuse, so 48 over 50. Cosecant, flip that, 50 over 48. Cosine is adjacent over hypotenuse, so 14 over 50. Secant, flip that, 50 over 14. Tangent over A, 48 over 14. Cotangent, flip that, 14 over 48. And there are your 6 functions. Okay, guys, so 3 videos for this week, all showing us kind of some old stuff with trig as far as the first 2 pages, but then this third page introducing a couple new things. We never did look at the reciprocals in geometry, and now you get to see those reciprocals, cosecant, secant, and cotangent. But as you saw, they're not too bad. It's just reciprocal means flip the fraction, right? So, all right, guys, good luck this week. Hope everything's going good. We'll talk to you later.